Today we're starting Chapter 3 and talking about Lesson 1, Exponents and Order of Operation. You might be thinking about the fact that we've already talked about the order of operations, but if you remember, we skipped a little piece, and that's why we're going to go back to it. So let's first talk about what an exponent is. Just like repeated addition can be shown as a multiplication problem. For example, 3 plus 3 plus 3 plus 3, that's 4 threes. 4 times 3 is 12, and you would get the same thing either way. When we have repeated multiplication, our shorthand, or our shortcut, is to use an exponent. So let's look at our vocabulary that we have for this lesson. The first word is power. A power is a number that can be expressed using an exponent. Okay, this is a very large example. 6,561 is a power because it's 4 9s multiplied together. Let me give you another example. 16 would be a power because it's 4 times 4. Which would be 2 4s, or 4 to the 2, or 4 to the second. An exponent is the number that tells you how many times you're going to multiply that base. Okay? It's usually shown, like this is right here, kind of smaller and up at the top rather than sitting on the line. And then the base is the number that is repeated, the number that you keep multiplying, the repeated factor in a power. Okay? So, 9 to the 4th means you have 4 9s that you're multiplying together. So you do 9 times 9 is 81, 81 times 9, and then that product times 9, and you get an answer of 6,561. All right, I think this is a review for you. Now let's look at it within the order of operations. We've done the Please Excuse My Dear Aunt Sally, or the PEMDAS. And the one we've been skipping up until now is the E, excuse. Please excuse my dear Aunt Sally. The E stands for exponent. And remember, when you simplify an exponent, you get a power. So we're still going to do any kind of parentheses work inside the parentheses first. The next thing we do is any kind of simplifying of powers. The next thing we do is multiply or divide from the left to the right in the order in which it comes. And our final step, if there's any addition or subtraction or both, we do it as it comes left to right. Okay? Now, I know that some of you are not a fan of those negative numbers, but now we need to see how the negative number plays into effect here. The power, meaning that little exponent, only affects what is immediately to its left. So, the negative sign is only part of the power if it's inside a set of parentheses. So we're going to look at 2 different examples here. This one has parentheses around the -3, and then it has an exponent of 4. The next one has no parentheses around this -3 and the exponent of 4. So they mean different things. If there is a set of parentheses around your negative number, it means that you have 4 -3s. So that means it's -3 times -3 times -3 times -3. Okay? And a negative times a negative is a positive. A positive times another negative is a negative. And then a negative times another negative would be a positive. So 4 threes, 3 times 3 times 3 times 3 is 81, and it would be a positive 81 because of those negative 3's. Now, here is the part that sometimes doesn't make sense to some. Since there are no parentheses here, the way that you really read this is the opposite of 3 to the 4th power. So that means that the negative sign does not go with the 3 when we are counting how many we have. We have 4 3's, and we're going to have the opposite of 4 3's. So 3 times 3 times 3 times 3 is 81. And then the negative sign goes straight to the answer, because we are going to want the opposite. So if the parentheses are there, then you may or may not have a negative answer. It's going to depend on how many negative signs you end up having as you're multiplying. If there are no parentheses, it's automatically a negative answer, because the negative sign just goes to the answer and it's not a part of the power. All right, time for some practice.